right, I'm going to talk through the day 2 homework worksheet just in case you wanted to see any of these out loud. Again, as always, feel free to fast forward, skip through any you don't need to see. I just want to at least provide that opportunity if you had any specific questions on any of them that I could kind of talk through them. So, first one, again, what I have been doing on all of these is setting r equal to 0 right away. So when I set r equal to 0, I knew that there was only one solution, so r equals 0 when theta equals 0. So I know it actually kind of starts off at that point at 0, 0 there. What that also tells me, if there's only one solution, one place it intersects the pole, is that this is going to be a cardioid. So I picked, again, my regular values here. A lot of these I think you can start to maybe do in your head. I've been writing mine out just so I can make sure I'm really thinking through them. So if we put in pi over 2 pi and 3 pi over 2, again, we just have to make sure we really think about the cosine of pi over 2, we know is 0, cosine of pi is -1, cosine of 3 pi over 2 is 0, and that gives us our values here. So I plotted those values first. Then, again, so I had this value, or I had this value down here, I had this value up here, I had this value, and I had this value here. So when I'm thinking about these, though, really the best way to go through this, though, is to come up with some other values. So that's why I picked the values, again, at cosine. You'll notice I'm picking the pi over 3 values, because at the pi over 3 values, that's where the cosine is either +1/2 or -1/2, depending on which pi over 3 reference angle value I'm choosing. So if I pick pi over 3 and 5 pi over 3, we know the cosine of pi over 3 and 5 pi over 3 are both +1/2, so that gives us -1.5 right there. So if I'm at pi over 3, but I'm -1.5, that brings me to this value down here. And then 5 pi over 3 at -1.5, that's right here. I would say those you probably don't really need as much. The better ones really to come up with the shape are going to be the ones that help us get this kind of more circular area over here. So in this case, 2 pi over 3 and 4 pi over 3 are going to give us the -1/2. So that gives us -4.5 and -4.5 for both of them. Again, 3 times -1/2 is -1.5 minus 3. That's where I got that -4.5 from. So 2 pi over 3 is right here, but it's -4.5. That's this point down here. And then 4 pi over 3 is right here. But again, these are our positives. Our negatives are going to be going in the other direction. Again, that helps us get that more circular shape. Notice, because it's a cosine, it's symmetric to the horizontal axis. And again, because it only intersected the pole in one spot, that helped me decide that it was a cardioid there. Number 2, here notice when I set r equal to 0, we get two values for our theta here. When you get two values, you know it's going to be that loop within the loop right here. So we know it's going to have that loop-de-loop in the inside here. So whenever you have those two, that's what it's going to look like. Here it's a sine, so again, it is symmetric to our vertical axis here. So I picked my values, my normal 0 pi over 2 pi and 3 pi over 2. Again, make sure you're careful with what is the sign at those values. That gave us these numbers. Now, when coming up with some other numbers, again, because it's a sine, I'm going to use my pi over 6s just because we know the sine of pi over 6 is 1/2. So that's why it's just a little bit easier to go through. Notice I didn't pick the -1/2 because I knew that those were already 0 because I already solved this equation over here. So that's why I only picked the pi over 6 and the 5 pi over 6. Again, reasonably speaking, you can pick any values you wanted to. You could choose theta as pi over 4. However, the sine of pi over 4 is √2 over 2. We get -4 times that minus 2. You're just going to get some decimal answers. So the whole reason that we're picking, in the case of the sine, the pi over 6s, is just because the sine of pi over 6 is 1/2. So that's why we're choosing those. So at pi over 6, if we're -4, notice that's going in this direction. And then at 5 pi over 6, again, it's -4, so we're going in this direction. Again, we know it had that inside loop right there, and that can kind of help us figure out our shape. Sorry for the craziness there. Number 3. This one I showed my work for. Reasonably speaking, you wouldn't need to. We know this one is just a circle. There is no value out here. Again, if you think in terms of like A, B, H, and K, there is no K value out here. So this was just a straight up circle. Mine doesn't look like a great circle here. It should probably be a little more circular. Um, but again, we know, again, if it's cosine, it's going to be symmetric to the horizontal axis. The negative puts it over to the left. That value right there means that that diameter of the circle is going to be 6. I filled in my points just so I could think about it. So we're at negative 6. Then at pi over 2, we're at 0. At pi, we're at positive 6. At 3 pi over 2, we're at 0. And again, I picked the pi over 3 because I knew that the cosine of pi over 3 is 1/2. Negative 6 times 1/2 would give us negative 3, so that's my value right here. I didn't even write down my other value because I knew it was symmetric. The other value I could have chosen was 5 pi over 3. And again, those aren't the only values to pick. Those are just some values that kind of help round out our circle. Number 4, this one's a little bit different because when I solved it for r equals 0, there is no value where the cosine is equal to negative 4. So we know it does not intersect the pole. That means that this one is not going to be a cardioid or that loop in the loop. It's either going to be like the flat part or the dimpled. Again, quite honestly, I don't really care so much right now that you know the difference in the names of all of those. But I just want you to have an idea at least of what that shape might be there. So when we're looking at this one, again, I picked my regular pi over, I'm sorry, 0, pi over 2 pi, and 3 pi over 2 values. That got us kind of our general shape here. I picked all of the pi over 3s just so I could get a better idea of what my shape might kind of look like. That can kind of help you decide that this one's going to be like a little bit flatter over here. This one almost looks like a perfect circle. It's not. This side over here is that little bit of a flatter circle there. All right, looking at number 5, you'll notice I didn't really do any work for this one. I noticed right away that this one is going to be a circle because it didn't have any plus or minus value afterwards. Again, if it's sine, it's going to be symmetric to our vertical axis. The 5, that's going to put it the furthest distance away from our pole. That's our diameter of this circle here. And again, I did it in my head, thinking through the 0, the pi over 2, the pi, and the 3 pi over 2 values right there. And then I picked the pi over 6's because I know the sine of pi over 6 is 1/2. So I picked pi over 6 and 5 pi over 6 and did half of 5, which gave me the 2.5 values right there. Number 6, this is another one that's a no solution here because we can't have the sign, there is no place where the sign is negative 3 over 2. It's only between negative 1 and positive 1. So I knew again that this was going to either be like the dimpled or the flat-sided one right there, called the convex, I believe, on that one. So again, that can kind of help us determine that a little bit. But here, again, I picked my normal values. And then again, I picked the pi over 6's here. So pi over 6, we know sine of pi over 6 is 1/2. 2 times a half is 1. 1 plus 3 gave us 3 right here. And then same thing for the value over here. I didn't even calculate the other values over here at the 11 pi over 6 and 7 pi over 6, but you definitely could to get an even better shape. Notice this one actually comes in a little bit more with like a little bit more of a dimple on that one. All right, last couple here. Here we have two values where the cosine would equal the negative 1/2. So that means it's going to be the loop in the loop here again. So sorry about that. Okay. And I picked the pi over 3's just to give us a couple extra values in there. Again, notice I didn't pick 2 pi over 3 or 4 pi over 3 here just because I knew that that would give us 0. So instead, just pi over 3 and 5 pi over 3 to give us those couple extra values. And then finally, here is one more where we only have one solution. Because it's one solution, we know it's a cardioid. So again, we kind of have a general shape of the graph. It only intersects the pole at one point, so it's not an extra loop on the inside. Here, if I fill out some of my points, we get kind of a general shape. Here, I did all of the pi over 6's just because I wanted a little bit better of an idea of where those points might lie. Again, it's not necessarily required that you would choose both of them. I would say the ones that would matter maybe the most would be these, just to help us get this curved shape over here to get a little bit more of an accurate graph, and those 1/2s are easy to graph there. So, what is it? The sine of 7 pi over 6 we know is, we got 1/2, and then, sorry, negative 1/2. And then negative 2 times negative 1/2 is 1. 1 plus 2 is what gave us the 3 right there. So that's how I got those values there. So let me know if there's any other questions. Hopefully, kind of talking through them helps. And hopefully, you're kind of thinking some of these are a little bit interesting. Next week, we're going to look at another class of these polar equations called roses. And those are actually kind of fun to graph a little bit because they're different from anything you've done before. All right, talk to you guys later. Bye.